recording.
Absolutely.
All right. So Jeff, Ivan comes first and Carl follow that. So Jeff, the closure, the MC, please take it.
Wow. All right. Well, let me lead by introducing Ivan and cast it off to him, and let's get right at it.
All right. Let me share the screen. Hopefully works. Are we okay?
Looking good.
All right. It's going to be weird because the screen that on the presentation is on all the way to the other side of the camera. So sorry about that. Whoa. Okay. We're going to talk about, I don't know if some of you guys know, we developed for Puerto Rico a tool, a very useful tool for remote assessments. The reason for it initially, a little bit of background of what happened here on the funding. FEMA gave the fund money to individual affected people, private resident owners, for contracting the engineers to assess their property. It was not a process that was handled by the government or any big program or people were deployed. They say, here's $500, get a structural engineer to come over and do an assessment of structural damage. So as you can imagine, all around the island, it was thousands of properties were affected, and people were left to, on their own to do their FEMA claims. Remember, most of these people have no idea what they're doing, and they get this check in the mail and said, figure it out, send us a report. So that home, actually, that's one of the sad stories. That home that we have there, Kit and me made the presentation all over the place that cases like this could be saved, and it was more cost efficient to save the home, repair it, make it more resilient than demolition. But sadly, last week I saw a video of that same house being demolished. The efforts in the municipalities were the initial response to the disaster. Kit made an article about it. It was really efficient. People would move fast. Campsites were set up. People were helped. But once that initial effort to respond to the disaster, they packed the bags and left everybody on their own. And it was very little support. And that's a sad thing. I mean, we made a constant effort to try to save and tell people what's the best way to do. But like always, demolition money is the first one that chose to town, and they want to demolish. So that's a side note on that. Again, these people don't know what they want, what could be done. The only resources they could have is support from FEMA, but the technical aspects of their claim were left to them with the $500 check. So it was a real situation. So here's a funny picture. This was our office, our initial Miyamoto office on the lobby of the hotel. And this is where the idea came from. We started brainstorming. Kit came out, well, we should use iBuild. And we had a call with the iBuild people, and we put together the idea of, essentially, Kit put together the idea of making this app with iBuild, and then we took it over. Kit, I haven't seen the chef ever since the earthquake, man. I don't know if he's still there. It was an excellent guy, huh? We were there, and he was serving us specific dishes and nice meals. That door right there was the kitchen door. So we were working with the kitchen of the hotel on our back. Constant flow of snacks and beers, no problem there. So once we started on the process, Mark and myself, we went in and developed some spreadsheets and some data from local contractors, and we started gathering the data and working with the iBuild team to put the software together. And it was a big time of the effort of our first lockdown. We would spend most of that at that moment. We couldn't go to the sites. That's the other problem. As soon as the earthquake happened, COVID hit. So once COVID hit, we were not allowed to go to visit the sites. So we used that time to develop and fine tune the software in order for when we get the government approval, we will go out there and use the application. And this is exactly our first visit using iBuild. Once we got it going on site. One thing that the SAC also put together was a way to book it online. Here in Puerto Rico, booking online wasn't that effective. I think is really useful for probably if something like this, we will go to that what things we need to consider in the future if it happens in the States. And I think this tool in the States will be really useful, especially now after COVID that everybody is doing things online. But here people use their phone. So they call us to do the appointments and they do a payment on the phone that is very popular here. So basically, how does this work? How the app? Well, we have to get Android tablets and we go to the property and we do an ATC 20 of the property and do the repair estimate right there on site. The application was really user friendly the way iBuild worked it out. It was really intuitive. We gave them the steps that we needed. And we will go a little bit in depth into that, not too much. But as you see, it's very graphical. It was very easy for us to train our interns for what they need to do in the field. And these are just part of the ATC forms, the standard forms. They're digitalized, so we just put the name, fill in the blanks of a ATC evaluation form. Very, very straightforward approach. The real-time data collection was really nice because once you're going to see, I'm going to show you, once you identify for example, that crack there, right there, we will document the size of the damage and we'll take a picture. So it's tagged on location and we can go back and reference and know where it's at on the plan view. And this is the nice feature of it. The way we work it out is once we fill out the ATC 20 form, it goes into a drawing mode where you draw the plan view, like a sketch of the plan, and then you pick your damage, predefined damage. We identify the typical damage that we were gonna see. So we identify those, and you see the small icons that are gonna show you later on as different damage where they're located. When you touch one of those spots on the application, it will jump into the specifics and the photo of the damage. As you can see here, we're going to go quickly to a typical process, but basically you create a new project and the main page, then it goes and gets you to the place where you do the sketch. Nothing fancy, just to familiarize yourself when you're looking at damages, where it's located. Again, this is really nice. You pick the damage, you put the spot where it's at, and what Mark and me work on, we develop the sketches of the type of repair that you will need there, and we take the dimensions of the existing column or whatever, and then right there on the bottom, once you enter the data, the fill in the blanks on just on the first, existing column height, width, whatever, it will take that data, spreadsheet format that we also have, and calculate, basically do a takeoff on what will be the estimate cost of everything that is involved to do that specific repair. And it will put the cost, right now you don't see it because of the photo icon, but right there, that column jacket specifically was like $2,000 or something like that. And that process will repeat itself throughout the floor plan. Every time you touch one of them, you're going to have the estimated cost of that repair and a picture that goes with it, the location. And they just keep going at it when they're in the field, filling out the information on all these different type of repairs that we identified. One thing that Kit told us to do is that since these were repairs, we included, you see, this is not your typical column repair. We kind of put in column jackets and corner jackets to make the repair, to have something better for whatever they're going to fix, to have a better result than just some crack repair of some columns. So the improvements, you can say, we included some improvements as a default of our repair recommendations for the owners as a default. And again, every single one of them is very itemized, and this helped us out a lot in Fema Claims. We had very good feedback with Fema. They had a lot of problems locally because the repairs they did not care for any damage that was not structural. And people were submitting all type of damage, like tile damage, paint, all this, that, and their claims were immediately disqualified. And since our format was strictly structural related and everything here, we have paint, but we have paint related to the repair of the structural damage. So the whole amount of what we're telling them that was their claim, they will get it approved, versus other companies that were submitting all these complete assessments that were not what they were looking for and got rejected or got no money. So very quickly the word got around that we were very effective on getting the claims. And what happened in COVID is that, we were remote. So we have a crew of interns that were trained to what to look for and what to account for as repairs. But we will, during the process of the visit, log in with them and talk to them and see the cracks or areas that they have some doubts or some, not really sure how to record that. And we also took that opportunity to talk to the owner, and they love that. I mean, even though the interns were, you see them with the Miyamoto branding professional, but they love to talk to us through the Zoom meeting. They would say, well, we're going to connect you now with the engineer. And that was really effective. Nobody complained that. We were concerned at the beginning that since the engineer was not physically on site, how will they handle it? But it was really, really effective. By the time we were talking with them, they knew we were able to see what was happening, hear their concern, and document it. So the remote thing worked really well. We had some doubts on that at the beginning, but it didn't turn out that way. Now, after we record all that data, the program, we made a presentation, Mark and me made a presentation letter, and it will fill out the client information and specifics on that presentation letter from our field visit. So once we finish the report, we will have a cost estimate, as you see here on the right, with the photos, with the locations, with the cost, and a letter to go with the report. And ideally, at that moment before we leave that site, we can email that person that report with all the estimates right there at the moment, which other companies will take like a week or 2 weeks to give a report to the person. Once you get all this data by hand, go back to the office, put it on some drawings, it will take a lot of time, and you cannot do that for $500. So this is what made it possible to do that. Now, there were some challenges. It's a new piece of software, and I think this presentation can be really useful for next steps, because the platform, there's a big effort already on the platform for Puerto Rico. So my vision of this is if this can be improved to be ready to go in a market like California or something like that, it will really be like a game changer for Miyamoto in a future event. And the effort required to have it ready for California is not that much anymore, or any other place, New Zealand or any other company. I think it's worth looking into being prepared to have the effort that we already have, debug on the things that we found, and have it ready to go at a moment's time. Anything happens in one of our locations. I think that's going to be huge. We have a challenge here because the application required for you to have internet access. and we were up in the mountains and places that sometimes we did not get the internet access. So we had some delayed on some site because you do have to get the data by hand and then go someplace that you get internet access to actually enter the data. So it is key to future applications. To, if a disaster happens, you usually don't have the internet. So it should be able to use offline as well as online in future events. And then the way we set it up with iBuild, we have some spreadsheets that are just the formulas for our repairs, and the price of the different repairs can be updated really easy. So if like, for example, if you guys want to have some time and want to have something preliminary done to California, it doesn't matter that you do it on today's time. The table for the price is very easy to upgrade. So you can have this thing on standby, sitting for 5-6 years. And if something happens, you just go to that table, update the prices, and you're good to go. So that's a good thing. And that's something that needs to be adjusted. I think that's Carl, right? We took his pictures just to be a transition to him. But basically, again, each region has its own characteristics, and we know it's very typical, the type of failure that we get once you go out there. They're very repetitive. So each area can identify their type of repair, the type of damage they can expect to, and have the software ready to go and ready to use. The reason I mention, and I emphasize this a lot, because if it happens tomorrow in some other place, like it happened to Carl, it's not at a point that he can pick it up and go. And I think that's something that we need to look into it, to take it probably to that point on different markets, that they can, that in case of an emergency, we can really have the tool available and ready to go, just an update on the price, and get everybody out in the field.
I think, Ivan, I think that having that offline availability is pretty critical, like you mentioned, because during a disaster, good chance you're not going to have internet.
No.
For various reasons. The only challenge there is logistical challenge will only be to get the GPS location for the site in. Yeah.
And again, when you did not get the GPS location on the site, we will probably Google it back when we go back to the office and put it in by hand. But
although,
that
GPS doesn't really require internet, I don't believe. That's satellite controlled.
Yeah, but once you did not get internet, you cannot get the GPS location into iBuild. You could get it through your phone.
I got it. Okay.
But the iBuild application couldn't process. I mean, it won't work. I mean,
got it.
Zero. And that's an improvement that we definitely need to go, because the part of the cost and the estimate and all that, that's just spreadsheets. I mean, they just took our spreadsheets and implemented on a graphical interface that is nice and easy to use and easy to learn. But that could be easy to be done by any of the offices. But the interface communication without internet, it was a game changer, because you can do anything. Once you start and you can input the coordinates of the place you were working on, you can do anything else. So you had to do it by hand and bring it back to the office.
Yeah, I mean, actually, the way that iBuild runs all their platforms are offline also. So I don't know exactly why they didn't use this particular version here. I don't
know, but it should be. I mean, that's one of the biggest. I mean, the biggest thing or hurdle that we found in order to deliver. I mean, the work got delivered, but just having the ability to finish it right there on the site and deliver it to the client on the spot. It's not there yet, even if you were online, putting together the PDF information from the site information with the document and all that, that's also an area that needs some fine tuning. We're not 100% at the point. We have to manipulate some of them to put a PDF together. It wouldn't take long, but also a nice thing will be, once it's finished, to put the PDF properly together to send to the client. We didn't have time to further develop that to make it work because of we were busy getting it out the door. But I think next steps will be also that, to go through the whole process and give it to the client right there on the spot, which was our goal from day one when we started brainstorming this thing. All right. I think we leave all the questions at the end, or we do our question if somebody else have some questions about iBuild.
You can take questions now.
Yeah, Ivan, I was just kind of curious, how long does it take to do one of these?
Oh, depends on the house you're inspecting. You know, it's a smaller typical house. We were in and out for half an hour. Bigger house, it will be 1 hour. But we've had some huge houses that would take a little bit longer. But usually they were outside of the typical scope. The typical scope was a person can go out there. We schedule a person to go out there in different directions, and they could do close to from 4 to 6 per day. Mainly not because of the time they're on site, but getting from one place to the other. We try to keep them close, but you know, Puerto Rico is small, but like as Kid will tell you, getting from point A to point B sometimes takes a while. So typically a person will go out on the street with, you know, range from 6 to 4, maybe sometimes even more during one day.
Yeah,
I'm sorry.
Sorry, I was going to ask a question. Did you have to adapt the building types that are in ATC 20 to Puerto Rico construction types?
Yeah, we did work, manipulated the format of the ATC 20 for our specific condition. So it's not an official ATC 20, but it was inspired by the ATC 22 you see in Puerto Rico.
Yeah, got it.
Yeah.
Similar in Haiti.
Yeah, I don't think that you can pre-program this for every country, by the way, because of every country or every region, you know, has a different archetypes, put this way.
Mm-hmm.
Yeah, that's kind of where I was going.
Yeah. But my question will be, like a place in like California, your typical home construction is pretty typical. The house and the damage will be the same as here. It will be the same type of damage typically on the house. Remember, we did not use the tool for historic or, you know, older buildings. We will use these for typical houses. If you call us out from the historic district, you are the unreinforced masonry house, we will not use the tool. This was for the typical house in Puerto Rico. Everything that fell outside the scope of that, it will be, you know, typical services and you know, of course, we will have to charge more and do a different type of approach. But this will cover, you know, 90% of the housing construction market in the island. All right, if you don't know any more questions, I'm going to stop the share and we're going to see some fireworks.
Thank you, Ivan. Great presentation. Sorry, guys. So I'm going to talk about Beirut a bit and the blast. So there's going to be a lot of information, so I'm going to go through this kind of quickly. So, okay, do you see the full screen?
Jeez.
Yep.
Okay, cool. Okay, so I'm going to start with the image of the blast. So of the, you know, right after the blast. So do you see my mouse also? Just want to make sure that I can show you.
Yes.
Okay, cool. So the blast occurred on the left side where you see the big crater. This was fill, and that's where there was a hangar, and that's where the blast happened. And then on the right side, this is there was a silo there that held 80% of the country's grain reserves. And on these are basically the port's hangars. And then in the back, you see the city. So basically it's a photo looking at the city. And then you can see just the scale of the damage. And you can see something very clearly that the steel has been, basically annihilated, destroyed, and the reinforced concrete buildings did relatively better. So I'm gonna jump to the next slide. So it was a pretty large scale damage. So more than 200 deaths, 7,500 people injured, and 200,000 people displaced. and 85,000 units damaged. Now, one thing to point out, and I'm going to say it starting this, I consider that we were pretty lucky because 7,500 people injured out of 85,000 units damaged. It's a pretty small number. And then that's considering the type of damage that we saw. So a lot of these were residential, so 60,000 residential, and 67,000 of the 85,000 units were in the, maybe 1 mile radius. So the dark red circle, that's where a lot of the units. At the blast side, there's a total devastation, and then the more you go back, when you get far, you get basically mainly windows blown out and doors. So the day of the blast, that's just a photo that I took maybe 3 hours after. So you can see there's a pharmacy, there's no windows. You can see glass everywhere. The car is basically bent, and then the entire ground is like this. So, it's difficult to walk, and then there's gas everywhere. So my personal experience, I was maybe around a kilometer away. So I'm going to go back here. I was maybe in this location. So the white arrow. So I was in this place and I was looking up when it happened. So there was 2 blasts. The first one was minor, and then so we looked up, and then the second one was the really big one, and that's where basically everything flew out of the buildings and then on the ground. The biggest hazard that I had was falling debris, because windows, curtains, just things are all falling around you, and then you can't really know what's going to fall. I was in the car, so you can't really know what's going to fall on you. And for people that were closer, it was probably direct damage. So the hazards that I saw were direct blast damage, and that's close to the site. The second major one was glass and projectile. A lot of people got injured from glass and projectiles. And then falling hazards, as we talked. And then fall was a big hazard. So basically the blast pushed a lot of people, on something, pushed them on the floor. Some people fell from balconies. So a lot of fall hazard. And then there was some structural failures, which we're going to go, to later. There was some driving hazard, so people driving crazy because of the blast, so trying to run away. And then after, there was a lot of looting and robberies going on. So while people were injured, other people, jump in and try to rob a bunch of things. And then particulates. So the blast basically sent out a bunch of, asbestos, glass particles, the ammonium nitrates. It was all suspended in the air. And then this was basically acute and the long-term hazard. So people that had to remain were exposed to these, to these hazards. I don't know if I drew these red lines, or I see some red lines here. So resiliency and preparedness. So first thing, there was weak public response. Basically, the government, in Lebanon, the government isn't really active, so they weren't really helping clean up. They basically just maintained safety, so they tried to limit the amount of robberies. And then the other things, there was mainly 1-lane roads, and then buildings, when the building collapsed in 1-lane main roads, the entire road is closed. So we had a lot of problems with closed roads because of buildings that collapsed. And then that's something where, in resiliency, you want to make sure that you have roads after a disaster. So people who were sick can go to the hospital. People who got injured were transported in motorcycles, a lot of them, because the actual ambulance couldn't get to the buildings. Electricity was down. There's water, no water, trash issues, trash everywhere. Hospitals, you can see in this photo, this is a hospital in the backside. Because of the blast, it was closed. So the ER was outside, basically. And a lot of people from the hospital, they had to we had to send them out to other hospitals, which basically became full. So the healthcare was overloaded. We drove to the edge of the country, and hospitals were still, booked, and pharmacies ran out of first aid kits, no tetanus shots, because it showed how much, how many things you need to think of when there's a disaster. There was no public transportation, but on the good side, because Lebanese people live in kind of difficult situation, so we don't have electricity 5 hours every day. So the fact that the electricity was out wasn't, such a disaster. And people are just used to living in, in difficult conditions. And then I put it with resiliency, but luck was a very big factor, as I said before. For example, in the Texas ammonium nitrate blast, in 1946, I think, or 47, few planes, collapsed. And if you look, they basically not collapsed, but they fell down. If you look at this photo, international airport is pretty close. So has there been any plane in the airspace? There's a likely chance that, it wouldn't have made it, and all of the people in it would have lived. So I think this is a luck, chance. And it happened after work, and a lot of the buildings near the blast were, were stores or office buildings, and a lot more people would have been injured had it happened, maybe 3 hours before. And the first blast, how I said there was two blasts. The first explosion was minor, but what it is, a lot of people became cautious, which kind of saved them from the second blast. So this is, what happened. So I'm gonna try to play this footage. Hopefully you can play it. So this is also the day after blast. It just shows, doors being, flown into the houses. We took these videos. Kids could have been playing here. And then this is aluminium, an aluminium facade. It was, behind this door. So you can see the amount of damage. And this all happens instantly. So you don't have, a chance. It's not like an earthquake where you can, duck and cover. So it just all happened instantly. And if you're caught in it, you're in trouble. So it just showed, the damage to basically to the facade that was really big. So let me just wait a bit for the next one. Besides that, there was the phone lines were basically full. So when you try to call someone, you cannot get a reception because everyone's calling. And that's another photo. So you can see there was a bed here, and the residents were sleeping when the first explosion happened. And but they stood up and got saved because they stood up from the first blast. This is a video looking at from the other angle, and there was actually a child in here. She went to the hospital, but she made it out, so she got lucky. But it just shows you, the scale of the damage. And the last one we're gonna look at is where you're gonna see how far a window flew out. So in this one, so you can see the window is here, and it was all the way up there. So has there been anyone anywhere here? He would have basically just been hit with the entire window. So even a big heavy fridge fell down. So the level of the pressure was insane. So I'm gonna jump into the next slide, and we're gonna talk about the blast energy and how they determined what was the energy of the blast. So there was 2,750 tons of ammonium nitrate, which is equivalent to 1,000 tons of TNT. And they did multiple studies to determine the value of the blast, how much the actual blast was. And the agreement is that it's around 300 tons. Some of these studies are way off, but the agreement is that around 300 tons of TNT equivalent exploded. So we're talking about 30% of the ammonium nitrate. So had all of it exploded, I think it would have been a much uglier scene. So a few ways they determined the level of the blast. First, by looking at the level of damage. So, for example, you can look at windows, glass broken. Okay, this maybe is 0.22 psi. And then using these, you can basically map out, based from the damages, you can map out the pressures that were present at the time of the blast. Other methods were using structural analysis. So they've used Conweb software, and then they modeled the blast, and then they modeled a few timestamps. So maybe 1,000-ton blast, 800, 600 tons, and then they looked at the silos that I was talking about that were holding the grains, and then they looked at the closest damage that you would have got depending on each blast, and they found out that the closest damage was due to a 220-ton blast. So that's from a structural standpoint what we can do. They also use something called the fireball size model to estimate the blast. So depending on how big the fireball evolves with time, you can estimate the blast, how many tons it's worth. And then they use a lot of videography and data to basically estimate what was in the hangar. So that's the famous ammonium nitrate, and you can see how they're stored haphazardly, and you can see how contaminated they are. And ammonium nitrate is not really toxic. It's not really doesn't really explode, but when you contaminate it and you put it under pressure, then it becomes explosive, and that's exactly what happened. So what was in the hangar? So 2750 tons of ammonium nitrates, 23 tons of fireworks, 50 tons of ammonium sulfate, tea and coffee, detonating cord, car tires. So all of these make it very easy to contaminate, the ammonium nitrate. And then on the right side, you can see the plan of the hangar, how they're basically putting fireworks right next to, ammonium nitrate. So it's been there for 4 years, and it's basically just waiting for it to be a disaster. And it all started when they were welding one of the doors. So they welded one of the doors shut. I think they were afraid of it being stolen, and it kind of started the entire fire, which I think lasted for maybe 15 minutes before the blast. So we can talk a bit about blast dynamics. So on the right side, you can see you get first the peak incident pressure, which is just you get the first positive peak pressure, which is the push, and then you can look at this in the dotted line, and then you can see that you get negative pressure, and then it basically subsides. And then as this grows, as the blast grows, you get first damage on the facade, and then you get uplift on the slab, and then you get once the wave surrounds the building, it basically pushes the building in, and then that's what you see at the third stage. Structural engineers usually don't look at the negative side of the pressure waveform in blast design, but I think it's something that we should consider due to the damages that I've seen in the blast. So I'm going to show the blast footage, just how it happened. This is the hangar, and at the corner over there, you have that's where the fire happened. You can hear the voice of something burning, and that's the first blast. And you can see the fireworks everywhere, and you can see the smoke rising, which had some ammonium nitrate and basically some fireworks. And then you can see the fire is gonna start getting stronger, and you can hear it becoming louder. And then the blast happened. So this happened very, very, very suddenly. So the videos are a bit, so this is just a slow motion, and you can see the wave hitting the buildings. So this just gives you an idea. If you look at this building, you can see it hit this one, and then this one, and then hit that. And the scale that it happened, it all happened really fast. So look at how fast it reached from over there to the car. So that's maybe like half a second. Now there's one thing about this. So do you see the white mushroom cloud that kind of goes out? So a lot of people thought that's a pressure wave, but that's not the overpressure. That's the negative pressure wave. And when you have negative pressure, your water vapor turns into cloud. So what you're seeing is the negative. And a lot of people were fooled by this because they thought that the pressure wave was the white cloud, and they were hit before that. So you can see on the sea, you can see the white, like where the pressure wave actually is and where that white cloud follows. So it's just something to keep in mind. And then here you can clearly see it. If you focus on the cloud at the top left side, you can clearly see the pressure wave. So do you see it? Like when it's going, while it's going up. So just some, just some feedback on what we saw. And I'm gonna show some of the damage to the structure, to the facades. So some footage to the damage to the facades after that. So this one, in this video, I just want you to focus on the positive shockwave and then the negative pull. So if you focus on the debris from these trees, you're gonna see them floating the opposite side of the blast. So that's a blast, and you can see the debris all going back, and then that's the negative. And then you get another small positive, and you can see the cars, they got bent, and that's because of the pressure wave. So it's not really because of falling debris. And in this one, you're gonna see the positive pressure wave push in, and then it's gonna reflect inside the building, and it's gonna merge with a negative pressure wave that's gonna come in. So the positive push in, and the negative push the top side to the, basically push the building out. So some of these footages, this just shows some of the damage to the facade, how quickly it happened. And if you notice, you can see a vibration before the blast happened, and that's actually the ground shaking. So you get a small earthquake tremor before the blast, and you can see it just slightly, a few seconds before that. So before everything gets destroyed. I think this just shows how the city looked like after it, and you can see the smoke, just the dust everywhere. Basically, it looked like from a movie. And then that's a cloud. So that's for the footages. We're gonna talk about some of the damage observed. So you can see a lot of steel structural damage close to the port. That's where the hangars are. So the most common damage is glass, structured glass, fade glass. After that, we saw like fade latches, locks, damaged frames, and then sometimes the whole window flew. So if the glass didn't break, the frame broke. If the frame didn't break, the latches broke. If the latches didn't break, the entire window flew off. So the facade is gonna get damaged. There's no question. It's just what's gonna get damaged. That's for example an entire facade. You can see how the mullions got basically curved in. Everything is post-heated, and there's a lot of damages. Interior damage. You can see in this image. This is a door, and it's basically riddled with small holes. These are maybe like a quarter of an inch deep. So imagine what they would do to everything else. Windows, TVs, things like this, they all got damaged. Falling hazards, so a lot of falling hazards on the cars, on things. And canopies, almost all of the canopies were basically destroyed because they're so light and they're directly exposed to the blast. So it just didn't stand a chance. And often they weren't properly anchored, so they just use some basic anchorage. Stone walls, we saw a lot of stone wall damage, and that's for cultural building heritage, which are older buildings. So these don't have reinforcement. And a lot of these were damaged not from the first pressure wave, but from the negative one, because the walls get basically pulled out of the, out of their foundation, and then the floor above usually collapsed after. So this one didn't collapse because it was light, wood light frame. Some of them, so when you look at this photo, and I don't tell you it's a blast, you might think that's an earthquake. These are sheet cracks emanating from an earthquake, but these are actually yield lines. So this is out of plane failure of the wall. So if you look at yield line failure on a slab, that's exactly what this looks like. And then a lot of your walls, if you look up here, parapets, all of these, since they don't have reinforcement, they collapse. And sometimes they use these to build over, which probably isn't really allowed. But there isn't always perfect control. And then you can see on the right side, the falling hazard, right? This is just sitting there waiting to fall. Arches, we saw a lot of arch damage. So these are basically also URM, and they're very vulnerable to the blast. Plaster, so a lot of the plaster got pulled out of the walls because when the blast comes in, it just pulls it off. And the plaster often was thick, like maybe like 2 inches, maybe sometimes 3 inches thick. It was very thick plaster with like a wood fiber reinforcing. And these are for cultural buildings, which saw most of the damage. Wooden roofs got damaged, a lot of wooden roofs because they're so light. More of the wooden roof damage. And steel, a lot of steel collapsed. And steels, because they just aren't as redundant as concrete, and they aren't as heavy as concrete. So a lot of these steel actually, the beams kind of buckled, torsional buckling, because when the blast uplifted the roof, they just weren't designed for the negative pressure. And they buckled, and then afterwards the columns collapsed. A lot of stone buildings collapsed, and it's the same reason. So your stone wall collapses, and then your roof falls. More of these collapses. If you look at part of the reason why part of these falls, these floor collapses. So your wall collapses. Then if you look at this photo, and I kind of zoomed in here, the reinforcements is on the bottom, and you don't have anything at the top. So when this wall falls, there's no integrity top reinforcement that's gonna stop it from collapsing, and which caused the roof to collapse. What we did in Beirut, we fixed plot 716. That's what Miyamoto relief did at this point, and we have more coming. So this one had some structural damage, minor to moderate. So on the left side, it's a stone wall, and it cracked and it pulled out of the transverse wall, and that's what we kind of wanted to repair. Some of the other one are non-structural. This is non-structural, but people who are there, thought this was dangerous. An engineer told them that this building is at risk of collapse. It's tilted, even though it wasn't tilted. So some engineers saw this photo and then told the residents that it's tilted, it's gonna collapse, and the residents basically were afraid to enter the building. So we did reparations for this one. You can look at the cracks, and then we got a stone expert, so stone mason. He laid out the stones same as they were originally, and then he repaired it. So that's the guy, and then that's when it was repaired. So it kind of looks brand new. You can barely tell that it was damaged. You can only tell because there's the new stones here. And then that's the block wall. So they demoed it, and then they built it back, and with the lintel, and then that's what it looked like. And then the arches. So it had stone, so we had to leave the stones and reinstall stones. And then we're gonna use the plaster to make sure that it's all coherent. And then that's what it looks like after the repair. And we also did this parapet with some reinforcement to protect it in a later stage. And yeah, so that's it. Any questions?
Fascinating.
Hey, Carl, why'd they put it in the corbels over the windows? They don't reinforce the masonry. They just they put in a concrete corbel.
Which one?
To go back to one or two.
Oh yes, we don't have reinforced masonry in Lebanon. It's not used. It's very little used. These actually block walls, they aren't the kind of block walls we see in the US.
That one right there.
They have little holes.
So is that concrete or is that grout or what is that?
So the lintel is concrete. Everything else is reinforced.
Is it precast? Do they cast it on the ground and put it there, or do they?
Yes. So you can see here they put the formwork and then they put rebar and then
so it's cast there. Okay.
Yeah. Yes, and then they use the plaster to just make it coherent. They don't have the same block walls we have in the US, and that's part of the problem.
Yeah, so by the way, the essentially colors stay after the blast, obviously, as you can see. And Myanmar Relief, we all know, we are part of it, to basically raised about $6,000. And this is the results of it. And we actually subsequently, Myanmar Relief funded $50,000 by the foundation, a private foundation, to actually address 10 different apartments like this one. So that's the underway right now. And once that goes, I think we get more funded. I think it can repair those apartments so people can come back. Right now, there's not much activities going on.
Yeah, so
as the whole reconstruction is concerned, because there's no public fundings and stuff like that quite yet,
And also, there's 300,000. So because of the blast, people stopped caring about COVID for a while, which made it spread like wildfire. So there's 300,000, known active cases, out of a population of 4 million. So I would say there's probably 1 million people at least. So we're talking about a quarter of the population have been infected. So just crazy. And we're in a strict lockdown. There's no work allowed at this point until at least February 8th.
Any other questions or comments to Carl?
No, really good presentation. Thank you.
Thank you.
Thank you, Carl.
Yeah, everyone.
All right. Well, thanks so much, Carl.
Thank you. Thank you, Ted.
You're doing a great job out there. Well, you're now back here now, but
But hopefully we'll be back.
yeah, exactly.
Yeah.
Well, thanks so much.
Thank you. Thank you.
Thanks, everyone.
Everybody.